Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, solving a system of linear equations using elimination with multiplication and addition. So this is one of our trickier types of elimination because we'll have to manipulate the equations before we can add them up to eliminate one of the variables. So looking at this one, there's no particularly nice one that's going to drop out, right? 7x and 3x, so we don't have a multiple or anything like that. And similarly, the negative 3 and the 2, we don't really have any multiples where we could just do one equation and be done with it. So since what we're looking for is the same coefficient, but with opposite signs, so we can add them together, I'm going to move to the 3 and the 2, not just because they're smaller, although that's nice as well, but because I already have separate signs. And if I don't have to multiply anything by negatives, it reduces the risk I'm going to drop one of those negatives. So the question is, I need a multiple of negative 3 and 2, or in this case, not worrying about our negative sign, of 3 and 2. So I'm going to go ahead and go with the smallest one and just do 3 times 2, which is 6. So the question is, what do I have to multiply my top equation by in order to get a 6y? So then I'm leaving the negative alone. So I have a 3, so I'm going to multiply the top one by 2 on both sides. And similarly, I want a 6 down here, so I have a 2, so I'm going to multiply 3 to both sides of that equation. Okay. And if we go ahead and simplify those, we distribute the 2 on the top equation and the 3 on the bottom equation. We end up with 14x minus 6y equals 26. And here we have 3 times 3, so 9x plus 6y. Okay, and we have negative 24 times 3, so make sure you keep that negative. And that would be 72. Now I can eliminate because I have a negative 6y and 6y, so if I add them together, they will drop out. Okay, so if I add my equations together, I have 14x and 9x, which is 23x, negative 6y and 6y, which is 0y, which is what I want because I will eliminate the y's, and then 26 minus 72. All right, now remember you can sketch some of these however you want when you actually put them together, but it doesn't really matter a whole lot how you deal with that part. But I would highly recommend double checking your math when you do it, and that's true actually with this multiplication as well. It's pretty common if you're making a mistake, it's either dropping a negative sign or we have 6 different multiplications here from our distribution. One of them will be a little bit off. So just make sure you're double checking as you go through, especially when you get some of the larger numbers there. You didn't mistake your 10 spot somewhere. All right, so this is 0y, so that's gone. All right, so we have 23x equals negative 46. Divide by 23, divide by 23. And we get x equals negative 2. Same thing with every system of equations. I'm looking for an intersection point. So that's my x value, because it's x equals. You may solve for y first every once in a while, so keep that in mind that you put it in the right spot. All right. And then we're going to plug that back in to both of our equations. Technically, you need one. I recommend both because if you plug the negative 2 into both and you get the same y out, that's how you can double check to make sure you did it correctly. So on this top one, we have 7 times negative 2 minus 3y equals 13. We'll go ahead and do this one from start to finish, and then we'll deal with our second one there. All right, so negative 14 minus 3y. Add the 14 to the other side. Divide by negative 3 and get negative 9. Now, if I plug the negative 2 into my second equation and get negative 9 again, then most likely I did it correctly. There's always a small chance that you made a similar mistake in 2 different ones that ended up with the same result, but that's pretty unlikely. So if you get the same result, it means you're most likely correct. You can always plug the whole point back into both equations to double check as well. Okay, so my negative 6 here, if I multiply those, add the 6 over, We end up with negative 18 divided by 2 divided by 2, and we do end up with negative 9. So we got negative 9 for both of them, so that means we should have the correct answer of negative 2 comma negative 9.